Hey guys, and welcome to the reading practice video on natural science passages. We're going to be reading a passage that has to do with Mars. So if you saw the previous video on the prose passage Elba, then we're pretty much going to be doing the same thing as we did in that video. Only difference is that this is a natural science passage, so there is not an emphasis on relationships or on dialogue in this kind of passage. So this time we don't have to kind of keep reading until we find a natural break in the conversation. We're just going to read paragraph by paragraph. Now, in order to really learn the method and be able to apply it on test day, please don't read ahead and please don't look at the answer choices. So we're going to read a paragraph, then stop, write down some notes, then continue, stop, write down some notes, etc., etc. Until we get to the questions where we're going to read them, not look at the answer choices at all, predict a correct answer, and then go ahead and match. That's the way that you're going to be doing the passages on the actual test, and that's why we're trying to mimic that in this video. So without further ado, I'll go ahead and start reading, and remember we're going to stop after the first paragraph. Okay. Natural science. This passage is adapted from the article The Mars Model by Bridget Mintz-Testa, which appears in Discover magazine, 1995, by the Walt Disney Company. The first close-up images of Mars, captured in 1972 by the probe Mariner 9, were a planetary scientist's dream. They revealed networks of valleys that looked uncannily like drainage basins and steam beds back here on Earth, and thus implied that there had once been water, freely flowing over the surfaces of Mars. The images also imply that Mars had once had a thick atmosphere. Our planet is blessed with liquid water on its surface only because it has a thick atmosphere to maintain a high pressure and trap the sun's heat. So planetary scientists propose that when Mars formed 4.6 billion years ago, it too had a dowry of a heat-trapping atmosphere, composed of carbon dioxide and water vapor. With warmth, water, and air, they speculated Mars might once have been a garden world, a paradise among planets. Okay, so that's actually pretty interesting. So the main idea here is that in the first paragraph, we basically are looking at, in 1972, the first time that we're seeing close-up images of Mars, we're explaining what it looks like. So the big things that, kind of jump out is that it seems like, looking at the surface of Mars, that Mars used to, at some point, we don't know when yet, but that's okay, Mars must have had some sort of water, be it rivers, lakes, basins, etc. But water used to be on Mars. At least we think so at this point. And we also think that because you have to have a thick atmosphere in order to maintain water levels, that Mars maybe had a thick atmosphere. So I would write something like first pic of Mars. What that means is first pictures of Mars, an arrow, so indicates or leads to, etc. We think Mars had water, which I'm going to abbreviate as H2O, plus thick, and I'm just going to call atmo, but atmosphere. Now again, whenever you guys are doing these, you're allowed to abbreviate as much as possible. You don't have very much room. Smiley faces, arrows, any of that kind of stuff is fine. I'm actually abbreviating less than I normally would because I want you guys to actually be able to read what I'm saying. So the idea is we have our first look at Mars, and that leads us to think that Mars had water and a thick atmosphere. So there are kind of our three little points. Okay, paragraph 2, which is a short one. But, as they also discovered, the garden didn't last long. None of the steam beds were younger than 3.7 billion years. Something happened to Mars, something that stripped nearly all of its atmosphere, killed its streams, and froze the garden forever. Ooh, dun dun dun. We've got some nice foreshadowing going on here. So we would say, you remember what the garden is referring to, you could mention it here. but I'm going to say garden on Mars does not last long. And because I noticed it, I might even put down foreshadow. Okay, so let's go ahead and keep reading. Researchers have suggested many scenarios for the Martian apocalypse. Some have proposed that the sun gradually whittled away Mars' atmosphere with its wind of charged particles. Others have hypothesized that the planet itself absorbed most of its atmosphere, turning carbon dioxide into carbonate rocks. For the past 7 years, however, Ann Vickery and Jay Melosh, 2 planetary scientists from the University of Arizona, have been exploring a far more spectacular ending. Most of Mars' atmosphere, they suggest, was blasted away by a succession of asteroids and comets. Okay, so they mentioned a bunch of different ideas, but they're all pretty specific. But the idea is this whole paragraph is discussing reasons for the Martian apocalypse. So I'm going to say reasons for decay. And then it seems like we're going to continue talking about these 2 people. So I'm going to say AV for Anne and JM for J, arrow, but think that the Martian apocalypse or the decay is caused by comets. So notice, when I'm writing down these notes, I'm not writing in full sentences, I'm just writing enough information that I could go back and know exactly what it was that I was talking about. Alright, so let's go ahead and continue with paragraph 4. The basic idea, Melosh says, is that an impact doesn't just open a crater. With high velocities, the projectile vaporizes and expands into the atmosphere. This superheated expanding plume shoves the atmosphere above it like the snowplow plowing snow to the heavens. How high a vapor plume goes depends on the mass and velocity of the object that crashed into the planet. If it is big enough and fast enough, it can drive its plume straight back up into space. The portion of the atmosphere it plows away is then stripped from the planet forever. Okay, so basically this whole thing is explaining how a comet or an asteroid, etc., can strip away the atmosphere. So I'm going to go ahead and say explanation, how comet strips atmosphere. And since I called it Atmo before, I'm going to call it Atmo this time as well to keep consistent. Okay, paragraph 5. To see if this process could account for Mars' missing atmosphere, Vickery and Melosh essentially ran a film of the red planet in reverse, starting with today's wispy atmosphere and adding back the air that might have been removed by impacts over the eons. First, they derived a mathematical expression relating time to the rates of both impacts and atmosphere loss. Using this expression, they then ran the clock backward to find out how long it would take to grow an ancient Earth-like atmosphere from Mars' current tiny one. If their model was right, it would produce the original early Mars. And the time it took to grow a thick atmosphere by going backward would be the same as the time it took to lose a thick atmosphere traveling forward. Using an impact rate that prevailed 3.7 billion years ago, 1 impact every 10,000 years, Vickery and Melosh were able to start with a virtually dead planet and grow a thick atmosphere in only 600 or 700 million years. Okay, great. So this is basically an explanation of the process by which they're trying to prove their theory. So I'm going to say proving theory, and I'm going to say math model. So math model, and then to explain adding atmosphere. So basically going backwards, kind of in a strange way like carbon dating. Alright, so let's go ahead and look at paragraph 6. However, now that an attractive explanation finally exists for how the young paradise of Mars was destroyed, some researchers are questioning whether that paradise ever existed in the first place. Studies of other stars suggest that the young sun was 25 to 30% dimmer than it is today. Mars, which is 49 million miles farther from the sun than Earth, would have been receiving less than a third of the sunlight we now enjoy. Some scientists have calculated that given so little sunlight, Mars' atmosphere wouldn't be able to trap enough heat to keep water from freezing, and that under such conditions, carbon dioxide would form frozen clouds. What little sunlight Mars received would bounce off the clouds and the planet would cool even further. As to how the Martian valleys we see today might have formed without a warm atmosphere, it is suggested that the planet might have been covered by large expanses of ice, and that the heat from Mars' interior could have thawed out hidden channels. Okay, so basically we have alternative theory, and the alternative theory is that because the sun was much dimmer, millions of years before now, Mars didn't have to have such a thick atmosphere, and if it didn't, then everything would have been frozen. So in terms of talking about the canals, though, we think that small pieces of ice were, thawed. So alternative theory, and I'm going to say thin atmo, frozen land, warm interior. Okay, last paragraph. Vickery, however, is sticking by her original assumptions. There exists on Mars valley networks that look like terrestrial river valley networks and don't look like any other kind of feature found anywhere else in the solar system, she points out. The first obvious interpretation is that these networks were formed more or less the same way as similar terrestrial networks. Okay, so we're saying that AV sticks by her theory. And I'm going to say that Mars looks like it had rivers, because that's basically your idea. Okay, cool. So that's the basic idea of how you would take notes for this passage. You obviously can abbreviate in different ways. You can reword things, but you basically want the most important pieces of information, and you don't want to get too caught up in all of the 10,000 years, 3 billion, 4.6. There's a lot of, figures in here, and you don't really need to get caught up in them at all. All right. So with that said, we're going to go ahead and move on to our first question. Now, if you guys are taking notes, you would normally have all these notes taken on your actual passage, and you refer back to them when you're looking at the questions. Okay, number 31. The author's purpose in writing this passage is most likely to... Okay, so basically this is primary purpose, so this is a big picture question, and the idea is either we know it off the bat, or we would skim through our notes that we have. And also we could read that first little blurb under natural science. So we know that the passage is adapted from the Mars model. And if we're going through, we've got the first picture of Mars. We think Mars had water and a thick atmosphere, but it decayed very quickly. We have reasons for decay, an explanation. We prove the theory, or we start to try to prove the theory. We give an alternative theory, and then we say, nope, this person is sticking by their theory. So it seems like the purpose is to explain a phenomenon, which is the seemingly, we don't know for sure, but seemingly that, water existed on Mars at some point. And then we're explaining the theories, and it's not unanimous. So we've got several competing theories, one of which the author explains more than the other ones. So let's go ahead and look at the answers. Point out irreconcilable differences between contending theories concerning the early history of Mars. Okay, what differences? Because we do have different theories, but the main point seems to be talking about those theories and the research that goes into them. We don't really have differences that, you couldn't have a piece of one theory and a piece of another at this point. So let's cross that out. B. Examine why the early history of Mars is important in understanding other aspects of planetary science. That has a pretty broad reach, and we don't really talk about other aspects of planetary science. We're very much limited to Mars, water, and atmosphere. Okay, C. Illustrate the differences in atmospheric pressure between Mars and Earth. Okay, that is super, super specific, because that is mentioned in one line of this whole passage, and that's not the primary purpose, because that's, if you look at line 8, it's there for, a couple lines. That's not the purpose of the entire passage. So then we're left with D. Report on recent theories and controversies in research concerning the early history of Mars. Now that's great, because that matches our prediction, and it has to do with everything we wrote down in our notes, and also it has to do with the title, The Mars Model. Okay, so we have the answer to 31, and it is D. Alright, moving on to 32. The last paragraph supports the general hypothesis provided earlier in the passage that, okay, so the last paragraph, that's our researchers, the two main ones that we're talking about, and we know that she's going to stick by the original assumptions, and the assumption is that Mars had water, had a thick atmosphere. Alright, so let's go ahead and check. F. A series of comets and asteroids repeatedly struck Mars. Okay, let's keep that for now, because it does talk about, in paragraph 4, it explains that that's part of her theory, but that seems a little out of scope, because it should be in the passage we're looking at. So a lot of you guys are going to want to keep that, or might have picked that on your own, so let's keep it, just to be fair. Mars formed about 4.6 billion years ago. Now, that's definitely, a misused detail, because that detail really doesn't have anything to do with her theory. Next one. Mars once had warmth, water, and air. Okay, that sounds pretty good, because that's what we were talking about of, Mars was not frozen, it was warm, it had water, it had, a nice thick atmosphere, aka air, like on Earth. So that looks great. We like that. Alright, and then J, large expanses of ice once covered Mars. Now again, that's the opposite theory. That's the theory that that's mentioned in the paragraph before. So in paragraph, let's see, 1, 2, 3, 4, 5, 6. So once we've gone through them, we realize that H matches much, much better the last paragraph and also our prediction. So F, although it does talk about it in an earlier paragraph, it doesn't really talk about what's in the last paragraph very well. So on 32, we would say H is correct. Okay, next up is 33. Which of the following findings, if true, would best support the idea that Mars once was a garden world, a paradise among planets? Okay, before we look, even though I know it says which of the following, this is a detail question, by the way, and you need to look at the answers, we can think about what sorts of things we're supporting. So Mars was a garden world, a paradise, and when they call it a garden world or a paradise among planets, they mean that it had water. So it had water and therefore plants, etc. So we're trying to support the idea that Mars did have water at some point. A. Images of Mars revealed networks of drainage basins and steam beds. That's exactly from the passage saying that supports that idea. So let's keep that. That looks pretty good. But we should read all of them for this kind. B. When the sun was young, it was 25 to 30% dimmer than it is today. No, because they used that information to support the opposite theory that Mars was a cold, frozen, miserable planet. If we're gonna, say it's paradise or not, doesn't sound very nice to me. C, a succession of asteroids and comets struck Mars about every 10,000 years. Again, that doesn't have to do with it being a paradise among planets. D, large expanses of ice on Mars were thawed by a heat source deep within the planet. And that, again, is referring to that other theory that Mars was frozen and, the reason for the drainage basins and the steam beds was an interior heat melting the icy land above it. So our best one is definitely A, and they're actually pretty nice to us because they don't have to give you answers for this kind that are in the passage, but they actually give you one that's directly from the passage. And the reason for that is it's a natural science passage, so sometimes they're a little bit nicer to you in terms of the answers for questions than they would be in, let's say, like the humanities passage. Okay, 34. It is reasonable to conclude from the passage that the amount of solar heat a planet retains is most directly related to its distance from the sun and to, so when we were talking about heat and how warm a planet is, we talked about how far away it is from the sun and also how thick its atmosphere is. So a planet that's closer to the sun or has a thicker atmosphere is going to be warmer than a planet that's farther from the sun or has a really thin atmosphere. So we're looking for a thick atmosphere. The amount of liquid water it has, nope. And that is dependent on distance from the sun and thick atmosphere. Its distance from other planets, not mentioned in the passage, and also really wouldn't have any bearing on how warm a planet is. The thickness of its atmosphere, ding, 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 that sounds perfect. And the volume and mass of its underground ice, that's not mentioned and doesn't have to do with our prediction, so we can get rid of it. Okay, halfway there, guys. 35. The main purpose of the third paragraph is to point out that there are several theories about, okay, so in our third paragraph, nice, because we wrote down when we were taking notes, there are theories, so we did a good job. That's all theories of why the atmosphere changed or why the garden, the decay that we said. So we're looking for, how it has a thin atmosphere, how it's cold, etc. So why Mars now has a thin atmosphere. Ooh, that looks pretty good. B, how carbon dioxide turns into rock. No, that's a specific detail of one of the theories, so not overall paragraph. C, how wind on Mars became charged with particles. Okay, again, that's a distortion because it's using a little piece of a detail in that passage, or in that paragraph, rather, but it doesn't actually answer the question at all. And then D, why the sun gradually took away the atmosphere of Mars. Okay, again, same basic reason for B and C being wrong, is that that's a piece of the puzzle, a piece of one of the theories, but it's not the overall point of the paragraph. So we're going to go ahead and say 35 is A. Next up is 36. The central idea of the hypothesis proposed by Vickrey and Meloche is that, okay, so they say from our entire notes that we took, or just from, knowing the passage, they said that Mars was warm, it had a thick atmosphere, and that over time, when Mars was struck by comets and asteroids, Mars started to lose its thick atmosphere, and eventually, we got the Mars that we see today, or rather in 1995 when this was written, with a thinner atmosphere. Okay, so F, a series of asteroid and comet impacts pushed away the atmosphere of Mars. That matches our prediction. G, the atmosphere of Mars trapped too much heat and burned away a layer of carbon dioxide. That's not mentioned. That's not right. H, the water vapor once prevalent on Mars was blown away by a wind of charged particles. Again, that's one of those theories that's mentioned for about one sentence in the third paragraph. but not with the main, it's not the hypothesis of our two main players at all. And then J, carbon dioxide on Mars was absorbed into the atmosphere and changed into carbonate rocks. Okay, again, they really like to mention all of the little teeny theories that are mentioned only for a sentence in paragraph 3, but that's not what our main guys think. So 36 is definitely our first choice, F. Okay, 37. Based on the passage, which of the following statements, if true, would weaken, notice all in caps because you want to make sure that you answer it like this, because it's kind of a double negative. Okay, so which of the following statements, if true, would weaken the hypothesis made by Fikry-Meloche? Okay, so we're trying to weaken the idea that Mars had a thick atmosphere, was warm, was hit by comets, and that's why the atmosphere was pushed away. Okay, as you guys can, or hopefully can see at this point, you don't need to know all the nitty-gritty details of everything. If you have the main idea of, okay, what's going on, what's the main theory, are there any other theories, if you kind of keep the basics straight and you rely on the notes that we made, you actually can answer all of these questions without maybe having a full understanding of the integrate process, or like, for instance, what was the mathematical model that they used, etc. So it's really not as scary as a lot of you might be thinking it is. Okay, so we're trying to weaken the main argument. The network of valleys on Mars was made up of drainage basins and steam beds. Oh, okay, if that was true, that would definitely help their hypothesis that Mars had water. So we can definitely get rid of that one. B, asteroids collided with Mars at a much higher frequency than was previously thought. Okay, if their whole idea is that asteroids strike Mars and that's what causes the atmosphere to be pushed away, then that would actually help them as well. So get rid of that. C, most of the comets and asteroids that struck Mars were very small. Ooh, now that would be a problem because they talk about, having a high impact and high velocity. So in order for their theory of how the atmosphere was pushed away to be accurate, they need to have large comets, large asteroids, really, going as fast as possible towards Mars. So C is a problem. And then let's just check D. It's not a problem. The atmosphere around Mars was once as thick as Earth's atmosphere. Okay, that's also what they said earlier, so that doesn't weaken the argument. So 37 is C. Alright, 38 is up next. If it could be proved that the young sun was 25 to 30% dimmer than it is today, then according to the passage, it might also be shown that Mars... Okay, so it gave us the lines 67 to 68. So let's see. Studies of other stars suggest the young sun was 25 to 30% dimmer than it is today. Mars, which is farther from the sun than is Earth, would have been receiving less than a third of the sunlight we now enjoy. And it goes on to talk about Mars, therefore being frozen, and the quote-unquote river beds, steam beds, and basins being created by a warm interior, melting the cold exterior. So, if we can prove that the young sun really was that dim, then that goes to say that Mars had a thin atmosphere and did not have water. Okay, F, has always had an Earth-like atmosphere. Definitely false, because it doesn't currently have an Earth-like atmosphere, so that rules that out right off the bat. G, has never had an Earth-like atmosphere. Okay, an Earth-like atmosphere is thick, and we're saying, we predicted that the answer is that Mars has a thin atmosphere or did not have water. So G actually matches. H, once had liquid water. That's the opposite of what we're looking for. J, has been routinely hit by large asteroids. Okay, that actually goes towards an entirely different idea, but it really has no bearing on the sun. So the sun does not affect how often asteroids hit Mars. So we have G is our correct answer here. Okay, 39. The word projectile in line 35 refers to Alright, we definitely need to go back and look at where that is. So, okay, this is when we're talking about the theory of how asteroids and comets hit Mars. So, with high velocities, the projectile vaporizes and expands into the atmosphere. So let's go up a sentence to help us out. So the basic idea is that an impact doesn't just open a crater. Okay, so what we're talking about in this whole paragraph, and we know this from the notes, is asteroids and comets hitting. So the projectile seems to be either an asteroid or a comet, or both would actually work as an answer as well. So A large mass of charged particles carried by the wind. Nope, that's again paragraph 3. At this point, you guys should be really glad that we didn't write down those details in paragraph 3, because they're not important. They just end up being wrong answer types. Okay. B, a large mass of carbonate rock. Nope, carbonate rock is not mentioned in terms of hurling towards Mars. It's mentioned in another theory where, carbon dioxide in the atmosphere is converted into carbonate rock. C, a plume of water vapor. No, the plume of vapor happens after the asteroid hits. And then D, an asteroid or comet. That's pretty much exactly what the prediction was. So that works out very well. Alright, last but not least, guys, it is question number 40. According to Vickrey and Meloche, about how long did it take Mars to go from a planet with an Earth-like atmosphere to a planet with the atmosphere it has today? Okay, there's 2 ways of looking for the answer to this kind of question. The first is you can use your notes and realize that the location of the answer should be in the paragraph where we talk about the mathematical model that they use to determine, how long ago it had a thick atmosphere. So you could definitely go by that, and then you're skimming through just that paragraph. And if I'm skimming through just that paragraph, I notice there are a few dates. There's 3.7 billion years ago, there's 10,000 years, and there's 600 or 700 million years. So that definitely tells us there are 3 dates that are associated with that paragraph. The other thing you could do is you can look at the answers for this because it's all numbers and just locate them. But by doing our first method, we've already gotten rid of 4.6 billion years because it's not mentioned in that specific paragraph. And then we can just go ahead and look at the area where it's talking about the years. So using an impact rate that prevailed 3.7 billion years ago, okay, so that's not mentioned anything about Earth-like atmosphere. 1 impact every 10,000 years. Okay, so that's just an impact rate of comets that doesn't have anything to do with what we're looking for. They were able to start with a virtually dead planet and grow a thick atmosphere in only 600 or 700 million years. So our answer should be 600 or 700 million years. And lo and behold, it's really easy to find the right answer, when they're all numbers. G is 600 to 700 million years, and that's definitely the right answer. Okay, guys, so always remember that if you take really good notes, you can rely on them and you can quickly use them to answer the questions. And don't forget to, kind of take a deep breath, stay calm, stay happy, and always predict before you look at the answers, because you can get them right that way, and you also are not allowing the test makers to trick you at all. So you guys did a really great job, and check back in for the next series of videos. Alright, thanks guys!